So I'll start recording.
So what's the title of, where are we downloading it from? And what's the title?
If you go to that link and then go to lecture 4.
Okay, lecture 4.
Yeah, let me, you know what? I can just start sharing my screen too, if that's helpful.
Okay.
Yeah, it should look like this.
Um, okay.
And in case you didn't already know this, you could click on each one of these individually to download it, or if you go to the root directory here and you click this drop down code, you can download everything here as a zip and then unzip it and you'll have everything. All right, let me check my chat, see how we're doing. All right, I got a couple thumbs up here. Anybody not have it yet?
I'm still working at it.
Okay, no problem. I'll give you an extra minute. We've got a lot of stuff today. Some of the most important concepts we've been building up to it up to now, right? So at least those for us that were unfamiliar with Python, now we're familiar with the syntax, indentation matters, different data types, right? You got integer strings, tuples. We talked about lists and dictionaries. We talked about sets. We talked about some loops such as for loops and while loops, how you can loop through a string, how you can loop through a list, how you can loop through a dictionary, things that you can change that are mutable and things that you can't change after creation that are immutable. And then we talked about list comprehension, which is just a fancy way to generate a list. Right, so we've dipped our toes. Now, essentially, we are going to utilize things that we have learned to build functions and classes, which are more complex objects in Python that either store data or do things, and they just have like a little bit more meat to them, right? And that's kind of like the basics that I wanted you all to walk away from this class with. We only had 4 sessions together, so there's only so much stuff we can get through and hopefully retain. I have some other things on the agenda today, such as how do you import packages? How do you make your own Python script and then like import things from that? Like just things that I think will help you when you're looking at stuff in the future, and hopefully you'll recognize it and understand, like, if you need more information about it, you'll know how to navigate it better, and kind of just self-serve. So I'm gonna go through the solutions to where we left off last class, rather quickly, just because we need to get to the rest of the stuff that I think is pretty important. If you have any questions about them, or if you didn't understand a solution or something like that, I'm gonna stay on at the end of class for a little bit, and we can kind of double back if you'd like. But we just have a bunch of parts, and based on the speed we've been going before, I'm afraid we're not going to get through everything. So I want to make sure we get through the most important stuff today. And if everybody's good, we'll get started.
I'll get there. Go ahead.
Okay. And I can help you real quick. Are you have you been able?
My computer froze up on me.
Oh, okay. Okay. All right. Well, stop me if we get too far and you haven't gotten it.
And Professor
Yes.
said I'm still trying to access the information.
Oh, okay. Have you been able to get to the GitHub?
Not yet.
Okay. You have the link though, correct? Or I can share it again.
Can you please share it again?
Yeah, no problem. Let me see here. All right, I just put it in the chat. And we're on lecture 4 today. And after I go through these solutions, I'll pause again and make sure we're all good to go. All right, so these are from last class. The first one was leverage a for loop and iterate through a dictionary with only printing the values and not the keys. I think we've seen this one before. Here's the dictionary with the keys defined and the values after the colons. We remember there's this method for dictionary objects, right? So here's my dictionary. I'm calling it here. There's a method called values, which returns only the values of my dictionary, right? So just the numbers. And I can loop through that for every single value and I print it out. Oh, I need to connect. So this is going to take just a second. Oh, and there we go. Oh, also, Chris, I don't think you're muted. Just a
Sorry about that.
That's all good. I was just letting you know. So second one, I specified use a for loop, the dot split method, and an if statement to create a statement that would print out words that start with S, right? So here's my string, print only words that start with S in the sentence. So for every word in string, this my string object dot split. And if you recall, this method returns a list. And by default, it splits my string by spaces. So this looks like a list that's like print, comma, only, comma, the, et cetera, et cetera. So once I have this list of my words from above, I say for every single word in that sentence, if the first character in that word is equal to a lowercase s, print that word, right? So when I run that, it's only going to pull out start S because it's treating this as a separate word and sentence. This works for this example. The only issue is like, what if I had a word that had a capital S, right? So like if I change this to a capital S, this is not going to pick that up because I'm specifying like only if the first letter is equal to a lowercase s. The way that we could get around that, I believe, is if we said if the first character of every word lowercase is equal to lowercase s, it will grab it. Okay. Use range to print all the even numbers from.
Excuse me. So, one quick question. Do you mean to say that that is case sensitive or not case sensitive?
So without this, this is very specific. This is saying if the first character in the word is equal to a lowercase s, right? And in this case,
So it's going to pick only lowercase s, not s, either lower or upper, right?
correct, because I'm saying this character if it only equals this thing.
Okay,
But yeah, case sensitive.
got you.
And then, but when I add lower, that's guaranteeing that I'm going to catch every s because I'm converting it to a lowercase first.
Okay, thanks.
Yeah. Oh, I always mess up my range functions. I think I forgot to add this. Okay, so for this one, I say use range to print all the even numbers from 0 to 10, right? So when you just call the range function, it just returns like, yeah, here's a range. So this is an iterable object, the range value, because it returns whatever you specify, right? And we're saying start, stop, not inclusive, and the step. So this is really saying, give me the numbers from 0 to 10, because this is not inclusive, and I want every other number. So for I in range, print I, and that's how we get 0, 2, 4, 6, 8, 10. Using list comprehension to create a list of numbers between 1 and 50 that are divisible by 3. We didn't specifically talk about the modulo operation, but it returns the remainder of a division between two numbers. For example, if I did 10 and it's the percent sign, that is what the modulo operation is. So 10% sign 3, this will result in 1 because 10 divided by 3 is 3 with a remainder of 1. So this is like back to our old school division days. Maybe that's useful or not for your upcoming math final. But I use that as an example just to show you a different way to do it. There are a bunch of different ways to answer this question. Use list comprehension to create a list of numbers between 1 and 50 that are divisible by 3, right? You could have used possibly like a range function. You could have done it a number of ways, but the way I did it is, right, so for number in the range of 1 to 50, non-inclusive, if the number is modulo 3, equals 0, meaning there is no remainder, right? Because if there is a remainder, this thing will return what the remainder is. So if there is no remainder, that means it's divisible by 3. And then I say, give me those numbers.
Quick question that did you use percentage sign there?
Correct.
Okay, so that means percentage sign is division in Python.
No, percentage sign is the, so I mean, kind of, it's the modulo operation. And I've never known how to pronounce that word. So if I'm saying it wrong, please correct me. But it's essentially saying, take 10 divided by 3 and return to me the remainder. If there is a remainder, return it to me.
Okay, but that symbol does division, right?
Kind of.
Okay.
Right. So if I did a division right here, 10 divided by 3, what's that? It's what, 3 point
Will use
something?
decimals, yeah.
Right, 3 point something. It's going to return a float if I did division. When I do the modulo operation, I'm going to get the integer 1 as the result.
Understood.
Yeah. So yes and no, you know what I mean?
But do you also can do division and then adjust to the decimals, saying that no integers? Is that
You
possible
could,
as well?
right? Yeah, that would be another way. You could use division, and then if the result, has decimals in it, then you could say that's not divisible by 3.
Okay.
Yeah. Go through the string below, and if the length of a word is even, print even, right? So I have my string defined here. I say for word and string dot split, just like above, right? So now I'm iterating through a list of the words. If the length of the word is divisible by 2, right, which would mean it would be even, print that word. So same logic I used above, I just reused it here. This is saying if it's divisible by 2, which would make it even. Write a program that prints the integers from 1 to 100. For the multiples of 3, print fizz instead of the number. For the multiples of 5, print buzz. And for numbers which are multiples of both 3 and 5, print fizzbuzz, right? So again, same logic, but now I want to see it in an else if statement, right? So for number in the range from 0 to 100, because 101 is not inclusive, then I have if statements, right? So if the number is divisible by 3, do this thing. If the number is divisible and if the number is divisible by 5, print this. If this is not true, if it's not divisible by 3 and 5, move on to the next statement, right? So now I'm saying, well, if it's only divisible by 3, do this. And if both of these things are not true, then if it's divisible by 5 only, print this, do this thing. And then I don't have an else here because I don't care about doing anything else if none of that's true. I could put an else and just put continue, which means like just move on to the next number. But that ends up being the result.
So that and what you put there, is that a command?
Yeah, so this is comparison operator, right? And like and or. So this is saying, and I could string it out, right? I could do another and then another and another and. So if this thing is true and this thing is true, right? If one of those things is false, we're not going to execute this part of the if statement. And that's why it's a different color. So you're right. It's a keyword. And just so I can go back on this, another way you could do this, right, is you could have a nested if statement, like indented from here, right? So I could do if this is true, and then inside of this if statement, like right here, I could do if, this is also true. So I make sure both are executed. I just chose to do it on one line and use an and. For the first 5 letters in every word in the string below, use list comprehension to add them to a new list. So again, here's my string. I'm doing list comprehension. So for every word in my list split by spaces, I just want the first 5 letters of that word. So I take the word, and this, like, if we look at create, for example, oops, I didn't run this. Sorry. There we go. Now it's right. So in this example, I've taken this, I've split it into a list by spaces. So my first word that I'm going to iterate through is create. So create is now right here. And I say, give me the first character to the 5th not inclusive, right? So I'm going to get CREAT. And then for the second word, there's only one. So I'm going to get everything. It's a list of the, and now I get to first, which still has 5 characters. I get here. This one's cut short because it's more than 5 characters. All right, we got to keep moving. Using for loops, greet all members of a class, printing hello and their name, right? So I have a list of names, strings separated by commas. For student and students, right? We're iterating through the list, print hello, and then I'm just concatenating with student. And because I left a little space right here, there's going to be a space in between hello and the name. Given the following list of numbers, calculate the sum of all the numbers using for loops and store the result of the sum in a variable called sum numbers. So I'm pretty sure this was a example from the last class, almost straight up. So I have my list of numbers. In this case, I am using a variable to keep track of the sum. So for num in the list of numbers, for each number as I iterate through, I take this guy and I add an equal whatever number I'm on. So I'm continuously just adding them up. This is shorthand for doing that. I don't think we went over that. You could have done it a different way, but again, I'm trying to expose you to different ways to do things. And over the iteration, it will add up all these numbers. You could do like some numbers now equals some numbers plus num, right? This is shorthand for that. This is the same thing as equals that. All
So why does this say some number equals 0?
That's how I initiate the variable. I say
Mhm.
some number starts as 0, and
Oh, it
now,
starts at 0. Okay.
yeah, it starts as 0. But as we go through this loop, we're adding to it. Create a while loop that subtracts 1 by 1 the numbers from 50 to 0. Both numbers included. Excuse me, sorry, I've been sick all week. With the following additional conditions. If the number is divisible by 5, show that number on the screen if it's divisible by 5. If the number is not divisible by 5, just continue executing the loop without printing anything. So I say, okay, I know I'm starting from 50. I'm going to make a variable, set it equal to 50. Using a while loop, which executes until the condition is false, right? So while the number is greater than or equal to 0. So once, even at 0, we're going to do something. But once we're below 0, we're going to stop the while loop. So while number is greater than or equal to 0. If the number is divisible by 5, right? We've seen this above. We now know what this means. Print the number. And because I don't have an else or an if else or whatever, right? Like we're not going to, there's no other condition to be met. So if this is true, do this thing. And then regardless, we're going to subtract 1 from this number, right? I showed you above the plus equals. Now I'm showing you the minus equals. And when we execute this, I'm going to start at 50, print it because it's divisible by 5, 45, 40, et cetera, all the way down to 0. And then it's going to stop. All right, a couple more here. Create a while loop that prints the numbers 10 to 0 on the screen, 1 at a time. This is like the exact same logic as above. I instantiate a variable called 10. I'm doing a conditional check. I'm printing the number and I'm subtracting 1 from the number. And then once we get down to below 0, it's going to stop. Same logic. Using the range function, create in a single line of code a list consisting of all numbers that are multiples of 3 from 3 to 300 inclusive. So I want 300 included. Store this in the list, my variable list, right? So nothing's going to be printed here because I'm not printing it out. But for number in range, right? So I'm starting at number 3. I'm going all the way up to 300 because 301's not included. And I'm saying, give me every third number, which is definitely going to be divisible by 3. In a single line of code, I create a list. If you're ever doing any practice problems and you see creating a single line of code something, it's usually given away that they want you to use list comprehension. I gotta keep clearing my throat. Create a list formed by the tuples index and element obtained through enumerating the indices of each character of the Python string. Okay, so first things first, I'm going to create a variable called string. It holds the string value Python. I say, okay, I want to make a list. So here's my variable, my list equals list enumerate. And we remember that from last class, enumerate returns a tuple object for every element of the object being passed, right? So enumerate returns to me a tuple where my first value is the index of the thing I'm iterating through, as well as the thing I'm iterating through, right? So when we do enumerate string, it's going to give me 0 because this is the 0 index, and it's also going to give me the value s. Oops. I mean, sorry, not the value s, the value p. Right? So the second item as I enumerate is going to be index 1, and my value is going to be y. So that's why you see 0p, 1y, 2t, 3h, etc. Right? That's what enumerate does. Last two, using max and min and dictionary methods, get the minimum value from the following dictionary, right? So here's my dictionary. Again, we're back to the key value of name and age. To get the max value, there's the max function we saw. I can pass what we used earlier, which was dictionary dot the method values to just look at the values. And if I take the max of that, I'm going to get the biggest value, right? And also you can do the same thing with the min, right? So the max value of this thing is 78 and the minimum is 2. Last example, use the random libraries choice method to get a random item from the list of names below and store the chosen name in a variable called raffle. So import random, which we're going to look at importing packages later, but import random is a package. I have my names variable, which holds a list of names. I create a new variable called raffle, and one of the methods inside of the random package, or one of the functions rather, is choice. And if I were to look at choice, it would give me information about what it's doing. And every time I run this, it's going to give me a random choice from the list. So if I run this, I was going to say, why is it Richard? But that's just random, right? So every time I run this, it's picking a new name, assigning it to raffle, and I'm printing what it chose. All right, I know I flew through that, but any quick questions about that? And we can always come back to it.
Is there hello? Is there a list of all these commands in one place?
Which commands do you mean?
Like all these Python commands, you know?
Good question.
All of these Python commands.
Yeah, because if there is 100 or 200 commands with its operands and options, then, you know, at least there's a cheat sheet or something, you know?
Yeah, I mean, the Python documentation is probably going to be your best bet. There are so many, right? There are so many packages out there that have defined their own functions and their own classes and everything, right? I guess what you're asking is too broad for there to be an answer.
Yeah,
would-
not everything, but just as a baseline, you know, because of course we can develop that, because I was just trying to create something and understand all these functions rather than going through multiple sessions, so that I can use it as a reference while I'm trying to do some practice. I mean, if there is one, you know, I haven't searched all the other internet resources, but I was just curious. There's
Yeah.
something handy, you know.
Yeah, no, I totally understand. I think the best, honestly, my data science answer is your best resource is going to be like a large language model like ChatGPT, right? Like show me 5 different ways to do this thing, and it's going to give you 5 different ways to do it. Or give me all the comparison operators, right? Like and or less than or equal to all those ones, right? It's going to give it to you in one nice place. But if you go to like Python documentation, that's probably the second best. I think I put that in the slides of our first class, if I recall correctly, but I can always.
Yeah, I have that. You
Okay.
gave that information. Thank you.
Okay, yeah. All right, any other questions? All right, we are moving on. Part 1 for today, functions, super important. Parameters, which go into functions, doc strings, and try and accept blocks. I think you're going to see these a lot in whatever you're doing in the future. So, function, right? The purpose of a function is for it to be reusable. You are creating a function because you know you're going to need to do something most likely more than once. And you don't want to either rerun the same code or copy the same block of code over and over, right? So we want to create a function, tell it to do something, and then all I have to do is call the function later on, and I don't have to, you know, rewrite or do anything manually. So I've provided a description here, essentially saying that parameters are the variables listed in the function definition, aka I make a function, the parameters are the things that go into that function. Okay. Doc string, this is a special type of comment. I think we've seen it before. You use triple quotes that lets you create a comment on multiple lines without having to use hashtags on every single line. And they are extremely important and extremely popular for providing examples and descriptions of like what a function or a class is doing. Just it's more in detail than a comment. And then try and accept blocks are used for handling errors in functions that you create or classes. Essentially, it says try to do this thing, and if there is either a general error or a specific error, stop what you're doing and tell me what's wrong, right? That's the purpose of try and accept blocks, right? So I've included a large summary there, but I didn't want to just read it to you all. So first example, creating a function. We're going to create a very, very basic function. In the below example, you have to use DEF to tell Python, hey, I'm defining a new function. Okay, so that's what DEF is used for. You can't make a function without it. The function name always follows immediately after DEF. In my case, it's called add numbers. So step one is you say def. Step two is the name of the function, followed by open and closed parentheses. Inside of those parentheses are your parameters. So you're saying, hey, anytime I call this function, there should be two parameters that get passed to it, right? Which might be intuitive because I'm calling it add numbers. You need two numbers to add together. The doc string, which is this, provides insight into what the function does and what is expecting as input. There's like a standard format for this in the Python world and like Python documentation. I believe I also included that in the first week slides. But it shows like at a minimum, you should say what are the parameters and describe what they are. And then what does your thing do and or what does it return, right? So in my case, I'm telling you this function adds two numbers, it returns the result. The parameters are num1 and num2. They're expected to be floats. And then it's going to return a float, and that float is going to be the sum of two numbers, right? So when I run this, it's not going to do anything because I'm not giving it actual numbers. When you run a function definition, this is now saved in Python memory as a function. I can now call add numbers as a function without having to describe the rest of the mumbo jumbo in here, right? So first example I have is if I just call add numbers and I don't give it the right number of parameters, right? I've specified this thing is expecting two parameters. It's going to throw an error because it's saying, hey, you're missing two required positional arguments, num1 and num2, right? This is now in the memory of Python, right? So if I do give it something it expects, it will add up the numbers as expected. I know that I said in my description, it's expecting a float and it would return a float. I didn't include any logic in here to like check to make sure what's coming in is a float, throw an error if it's not a float, like et cetera, right? So the function still works. There's nothing wrong with it. You can add two floats, you can add two integers. They're both numbers. But I'm just pointing that out that like, even though the documentation said this, right, the function still worked and it still returned a result. Keep that in mind as we go forward because we're going to see some other things. Something else interesting, right? So we have been creating variables up to this point. They haven't been within a function. When you create a variable inside of a function, you can't refer to it outside of the function, right? So I have created this function. Within it, I add two numbers, I assign it to result, and then I return the result. And that's the end of results life, right? So if I come down here and I say, I want to just look at what result is, it's going to say that's not defined. So this is something we haven't seen before. But if you create a variable inside of a function, you're not going to be able to refer to it. Okay. If I wanted to save the result to refer to it later, I do something like this, where I call my function. It's going to add these two numbers. It's going to return to me the result, right? That's what this is doing. And then I save that result in a variable called addition. And now I can refer to addition. All right. Any questions about that example? I have several more. All right. Example 2, adding a try and except block. So when you divide by 0, that's never a good thing, right? We know that that's undefined. If you were dividing by numbers in like a large program or like you're doing 1,000 things and some of them's division, you might want to protect yourself against, you know, maybe if a denominator is ever 0, that's like something else is wrong in your program, right? Like some math has gone wrong somewhere or some data is wrong. And this is a way to catch something like that. So in this case, I am defining a function called divide numbers. I am specifying that the parameters are a numerator and a denominator. I have my doc string here explaining what that means, but we're all familiar with division. And then I've added this try and except block. Okay. So what this is saying is, okay, I take my two parameters, try statement. So try to do this, right? Python, try to divide the numerator by the denominator and save it as a variable called result, right? If you can do that without error, then there's no need to run the except block, okay? If you can do this, that's great, and then return to me the result. But if you get an error during this process, right? And the specific type of error I care about is zero division, which is a built-in error, which we will go over in the next part or 2 parts from now. But if there is a specific zero division error, then I want you to print this. And then I don't want you to return anything. Okay. Right. So if we're all good on the try, just give me the result is what this is saying. If there is an issue with the try, and if the issue is division by 0, print the error and return nothing. So example usage of this, right? I've defined my function here. It now will exist. I say, all right, let's create a variable 10. That's the numerator. The denominator is 2. Print dividing 10 by 2. I'm going to save the result of my function, right? We know this isn't going to throw an error because 10 divided by 2 is 5. If the result is not none, which we went over last class, right? If it is not none, then print me the result, right? So this is going to print me a result. So 10 divided by 2 is 5. More interestingly, if I say, okay, I'm going to like force this except thing to run, right? I'm going to force the except statement to run. So I'm going to make my denominator 0 now, right? So numerator is going to be 10. Denominator is going to be 0 because I'm overwriting it down here. I'm going to print the same thing, print dividing 10 by 0. I'm going to try to save the result, and I'm going to try to run this whole print statement, right? But we know we are going to get back none because we're going to be dividing by 0. Error cannot divide by 0, right? It's printing this because this error happened and it was caught in my except statement. All right. A little bit more on except blocks. So same function, same example. In this case, the except block is just a little bit different. So if we recall from above, I specified the specific error that I want caught, which is a zero division error, which again, I will list out all the different types of errors in Python below. But in this case, I'm saying on this exception, do this thing, right? If I have a different type of error, this is not going to catch it because I'm specifying the exact error that I want caught in my except block. If you use a bare except block like this, where I'm not specifying the error, on any error, this will trigger, okay? You're probably not going to use these much in the program, but you're probably going to see them and you should know what they're doing. So this is called a bare except block because there's no error specified here like there is right here. This will catch any type of error, right? Like, for example, you know, if I passed a string or like some other data type that can't be divided by a number, my except block will trigger. So this still catches. So I'm doing the exact same example from above. The denominator is 0. This is still caught by that error as an example. Print an error occurred. Example 4 is type hinting. So type hinting is a way to help other people using your functions to let them know like what is the expected data type of the parameters that I'm specifying, right? So above we just had, hey, I made this function, I did numerator comma denominator in parentheses, and that was it. This is a popular way to say, hey, this is still my one, parameter 2, but I'm also letting you know up front that it's expecting a float, and then the output is a float. Optional, meaning it doesn't necessarily return a float because I have this try and except block in here, and it could return none. But again, this does not enforce anything. It doesn't check to say, hey, is this thing being passed a float or not? This is just letting someone else know, like, hey, the expected thing that you should be passing to it is a float, and the output is optionally a float. Okay, so that's type hinting. If you see it, don't let it scare you. That's what that is. I want to see if there's anything I want to go over here. So, okay, here's a good example. Let me get rid of this. So in my example here, same function, divide two numbers. My try is try to divide the two numbers. My except only specifies do this thing if it's a zero division error, right? Keeping that in mind, if I come down here and I make my denominator a string, that's obviously not going to throw a divide by 0 because my denominator is not 0, right? So when I try to run this, this gets printed. That's why we see this. I try to run my function and it throws an error, but the error is not caught in my except block, right? That's why we don't see this custom print statement that I put. Instead, it throws just a type error internal to Python that says unsupported operand types for division, float and string. Obviously, you can't divide a not number by a number or vice versa, right? So that's, hopefully that's a little more clear that like this didn't catch it because I told you what specific error I wanted. If I took this away and then reran this, hoping I don't eat my own words. Okay, good. So instead of that nasty, informational thing Python gave about a type error, right? Now I've caught all that in my bare except statement, and it's going to print this. Now, is that super helpful? Not really, because this isn't really the issue. Can't divide by 0. The issue is I try to do a mathematical operation with a string and a number. But that's an example of what you use these for. You could stack up try and except statements to like catch multiple errors and like maybe give you more helpful information, like actually print what the value was so that it's easier to debug, et cetera, et cetera. So, and I have one more example, then I'll stop for questions. So something else you can do with functions is you can set default parameters. A default parameter essentially means, right, instead of having just two parameters you specify for your function that are required to be passed through, you can say, hey, if this parameter is not passed through when you call the function, then the default value is this thing, which is a string hello, right? So in this case, I can just call the function and only give it one value, and it's going to treat that value as name. And then it will use this as the default value, right? So when I run this, here's my function. It takes two parameters with the second one being the default value hello. And it's just going to print the F string, whatever the greeting is, followed by whatever the name is, right? So when I pass it Alice hi, it's going to say, hi, Alice. It's going to take what I gave it as greeting and stick it here, the name and stick it here. If I only pass it Bob and I don't pass it the greeting, it's going to use the default greeting hello and then the name I gave it Bob. Okay. You can also specify variables out of order, right? So if you don't tell it exactly what the variable and the value are, it's going to take things from left to right, right? So when I pass it Alice hi, because name and greeting and the function are specified, you know, name first, greeting second, it's going to treat this as name and this as greeting. It's going to treat this as name because I didn't give it a second thing. It's going to take the default for this. However, I could come down here and I could specify greeting first, but I have to tell it like this is what I want the greeting to be. And this is what I want name to be. And as long as I use the same parameter names, it will work. So in this case, this is just an example where I specified name first, greeting second, like I've done up here. I get, hey there, Bob. And now I just switch the order. But because I told it what part of the parameter is greeting and what part is name, I get the same answer. Okay.
I did not quite understand this example. Sorry.
Yeah, no, that's okay. No need to apologize. So you're talking about this last example here?
Yes.
Okay. So do you understand what the function is doing? Otherwise, I'll start.
Yes.
Okay, all right. So you got that. So
So when you are writing printf, that is you are formatting. Is that the
Correct.
F formatting? Okay.
yep, that's the F string.
Okay.
And it takes variables in the variables in the curly brackets, right?
Yeah. Variable name is in curly bracket and greeting is it will take the value of the greeting that is defined in the function, which is hello and name.
Correct.
It does not have to be in the order, so it will recognize your variables and put the value that you pass.
Correct, right? So just to go a little bit further there, if I call the function without specifying what parameter is what, it's going to assume that the order in which I pass them matches the order of the function definition, which is name first, greeting second. So that's why we get hi Alice. If I only pass it one thing, it's gonna same thing. It's gonna assume the order is the same. So it's gonna say the first thing you gave me is name. You didn't give me the second thing, but because I have a default value I know to use, I'm gonna use the default value.
Okay.
And let me do this. If I take this away, here, let's do this first. If I take this away and don't give it a default value, this is going to work because it's expecting two things. This is going to throw an error because it's expecting two things and I only gave it one and there's no default value. So missing one required positional argument greeting. So it knows like you gave me one thing, I used it here, but you didn't give me a second thing.
Okay, thank you.
Yeah. No problem. And then down here, this is just another way to call a function is if you know the parameters, you can specify them specifically. And this is kind of useful for when you are passing things out of order like this. Any other questions on functions? All right. Okay. Sorry, I had a message in the chat. All right. So I'm going to get through part 2 and then we're going to take a break and then we'll come back and do some exercises. All right. Classes, methods, and attributes. So classes are a little bit beefier than functions. And we'll see why here in a second. So a class is a blueprint or a template for creating objects and object-oriented programming. So we're circling back to that concept from like lecture 1 or 2. It defines a data structure that encapsulates data, attributes, and methods, functions that operate on that data. A class represents a type or a category of object and allows for the creation of multiple instances of that type, each with its own data and behavior. Okay. The most simple thing you can do, you create a class by specifying class. Function was DEF, like for function definition. Class is literally the word class, the name of the class, and a colon, and then you build on it from there underneath. But the most simple thing is I just gave it pass, which means, right, do nothing. So it's just like an empty thing. You can add methods to a class. A method is a function that is defined within a class. So inside a class, now we're familiar with what functions are, and is associated with instances of that class. So methods define the behaviors or actions that an object of the class can perform. They often operate on the object's attributes and can modify the object's state. So in this example, I'm building on my class. So now I have a class called car. I created a function that's start engine. We'll talk about self in a little bit, but the function is called start engine. And all it does is it just returns, when this function is called, it just returns the string the engine has started, right? It's not doing anything. It's not adding things up. It literally just returns a string when you call that function. Attributes. So think about it this way. A class method, which we've heard that word before, right? Like we've called methods on dictionaries, like dictionaries have methods, lists have methods, like split. We've used the function dir to look at the available methods for us to use to sort things to uppercase to lowercase, right? So now we're connecting the dots of like, we've heard what method is. Now we're actually going to see like what a method is, right, in the background. So attributes, so methods do things like a function. They actually do things and operate on the data. An attribute, oh goodness. An attribute is a variable that belongs to a class or an instance of a class, and all it does is it stores data about the class. It's not actually doing something. You don't call it to add numbers together or like run it like a function. It just tells you information about the object, about the class. So in this case, most often, instance attributes and class attributes, we'll talk about the difference here shortly, but attributes are defined in this initialization dunder method, right? The double under. We're going to get into that a little bit. But in this case, like I've created a class called car. I've defined this initialization dunder method. And what this is saying is this car class, every instance of this car class is going to have an attribute called make and an attribute called model. So whenever I instantiate a car, I need to tell you what the make and what the model is, right? Which intuitively makes sense. And I can have multiple different types of cars, right? I can have car 1, car 2, car 3, and they can all be different makes and models, okay? All right, a ton of examples, but in summary, right, a class is the blueprint for creating an object. You define what its attributes and methods are. A method is a function defined within a class that describes the behavior or an action of the object, and an attribute is the variable that holds data and state information about an object. All right, so what does this mean, Stephen? First example, class instantiation. I think I spelled that right. Self and init. So I've included lovely information here that goes much more in depth about what these things mean. More than what I'm going to say, because honestly, it's not, I don't want you to get confused as we get going. So I'm going to give you the short of it. I'm making a class called dog. Whenever you see this, whenever you see definition, dunder method, which is the double underscores before and after, or the magic method, otherwise some other people call it init. Whenever you see init, you should think, okay, attributes are getting defined. Just put that in your brain. Whenever I see init, I'm not going to worry about getting hung up on what init and like self means. Whenever I see this, I know that attributes are getting defined, right? I want you to be able to read code. I'm not super worried about you creating classes from scratch for this. So, okay, I see init. I know attributes are getting defined. What are my attributes about my class dog that are available? Well, name and age. Okay, so I know that whenever I have a dog, there's going to be associated name and associated age with that dog. That's what I want you to take away from this. Here's a method. How do I know it's a method? Because it wasn't defined in my init, because my init is where attributes are defined. So I know that this is a method because it's outside of that. I also know that it's a function that does something. So I know that it's a method, right? Difference between attribute and method again, right? So I have this function called bark, and all it's going to do is return my name attribute, whatever the name of the dog is, and then says woof, right? It's not performing an action on data. It's just like returning to me some information, right? But it's still a method. So if I create an instance of a dog, what does this look like? So I know the name of my class is dog, so I give it dog. I know that it has attributes name and age, so I need to give it a name and give it an age, right? And now my dog exists. So if I run this, I have my dog, and I can access its attributes by just passing dot and then the name of the attribute, which in my case, I'm returning what is the name of the dog. And then if I want to run the method bark, it's also a dot and then bark, which is the name of the method. And in this case, I know it doesn't take anything. I know you see self here, but there's no other parameter, right? So when I run this, I get the name of the dog back and then the method bark has been run, right? So hopefully this looks a little bit familiar to when we were calling like the dot sort method or dot upper or dot lower or any of the other methods we've looked at for tuples, dictionaries, lists, et cetera, right? Like behind the scenes of the list class or the dictionary class or the whatever class in Python, there are methods defined in the background that sort things, that uppercase things, that lowercase things, right? That code is written and stored somewhere inside Python, and all we have to do is call the method. And in our case, we're calling .bark. All right. Hopefully some dots have been connected there. I have many, many more examples. Touching on self. So I know we see self up here. Self is a reference to the current instance of the class, right? So self is only useful once a class has been instantiated, right? So meaning what I mean by that is I've created an instance of the dog class called my dog. I could create another instance of the class called, you know, my second dog or something like that. My third dog, my fourth dog. Each one of those are separate instances of the class dog, right? Which is kind of intuitive. I can make multiple objects in Python. I can make multiple variables. I can make multiple instances of a thing, right? Just like I can have multiple lists, I can now have multiple dogs. Okay. So when we talk about self, we're saying for that specific instance, like my dog, not my second dog, not my third dog, but my dog. When I say self, I'm talking about that specific dog. That's what self means.
It will be helpful to me if you just give an example of if you did not use this class, then is there a way that you would achieve that? And what is the reason that you are actually using this class? Like, is it making it more efficient, or you know, you don't have to type as much, or what is like general? I am assuming there is a reason why we are using this, that we do it this way instead of writing it out, right?
So I'm thinking about the answer to your question. So when you say instead of writing it out,
like not using the class, there must be other ways to do it. without using class?
So no, there isn't really.
Okay.
Meaning
Mhm.
like you could print Rex or you could,
Right.
yeah,
So
like you could print Rex. I guess you could make a variable called, here, let's do this. So you could do like my dog equals Rex, or how about this actually? My dog name equals Rex. My dog age
yeah,
equals 5, right?
yeah,
Okay, I've created two different variables that
yeah.
they're not related to each other at all.
No, no.
In this case, they are. They all roll up to the same object, which in my case is my dog, right? So
Okay.
it's like both of these pieces of information are now stored in this instance and are related. And I can
Okay.
refer to them over and over.
Okay.
Yeah, so I guess that would be one reason why you would do it like this.
Okay.
If I, if I had a second dog, I could then, if I wanted to do it the manual way, it would be like my second dog name, my second dog age. However, these are not related to, one, they don't roll up to something. Two, there are no functions available to do anything about this. To, if I wanted to rename it, I'm going to have to rewrite my variable. Or overwrite my
Or
variable.
you can zip it, right? To make it one variable, like a, I don't know. I'm just saying, I'm just thinking, what is the usefulness of this
So,
when you use it?
right. So if you think about it in the background of, I'm trying to relate it to something we're familiar with, right? Like a list, like the object list, like, um, uh, right. Oops. Oh, goodness. That was horrible. Right. So what is the thing I'm trying to do? Right. So this list right now, in the background of Python, there is a class that defines what a list is, how it's stored in memory. Like it pretty much gives you the ability to make a list, right?
Yeah.
And we can call functions that do things to the list,
Yeah.
right? If that did not exist, lists would not exist,
Yeah.
right? We wouldn't be able to
Yeah.
use lists. There wouldn't be available functions, right?
Mhm.
So you could see like how important having a class is in the case of like lists just existing. Same with dictionaries, tuple sets, like the ability for you to store objects in a certain way, access them, manipulate them, right? Like this, it might not be apparent in this example because this is a silly, easy example, right? It's like, okay, I made a dog object, so what, right? But I could have like, I don't know, 20 different functions that roll up to a dog that do different things.
Okay, I see.
Yeah.
So it's like, for example, there are built-in class or built-in like list tuples dictionaries. They have a class running in the background, like that's already built in.
Mhm.
And when those do not serve my exact need, then I am building my own, say, class to perform specific task, right?
Correct. And now unless you're like a super, like, unless you're working on the next version of Python with like those, what I would consider like geniuses, right? We're not necessarily creating the next like Python data type, right? We're not doing advanced things like that. But what we are doing is saying, maybe there's some object that I want to keep track of. I want to easily manipulate without having
Okay.
to, do things over and over manually. And it's more, I don't know, programmatic to do it this way for, I know I might have multiple instances of the object. They all need to fall in line, right? Like they all need to have the exact same attributes about them,
Yeah.
that kind of thing. So this
Okay.
rolls
Understood.
up to that object-oriented programming.
Thank you.
Yeah, no problem. This is good questions, especially if it's the first time you're seeing it. You're like, why do we go through the trouble of this? All right, let's Yeah, let's keep moving. All right, so example 2, I wanted to point out what a class attribute is versus what an instance attribute is. So I've put it in comments here, but anything inside of the init function is an instance attribute. We just saw that above, but something above it, right? Something not inside of the init function is a class attribute, meaning like I can have 3 different dog instances, dog 1, dog 2, dog 3, but because there's a class attribute, they're all going to be the same species, but they can have different names and different ages, right? So each instance attribute can be different, but the class overall attribute will be the same for all of them. So my example here is I've created dog 1 and dog 2. They're both of class type dog. They have different names. They have different ages. Okay. But when I print the species of both dogs, because that species is a class attribute, they're both going to be the same. Right? So they both ultimately roll up to the class dog, which has an overall species type of this. Right? You can change class attributes or even instance attributes after you've created them. But in this case, if I change the overall class attribute from, I'm not even going to try to say that, to this, then it will be different, right? So here they're both what I originally stated them as. If I say, hey, for the dog class, change the species to this. Now when I print both dogs.species, they're both going to be updated, right? Even though they're 2 different objects, 2 different instances, because I changed the overall class attribute, both of them get changed because both of them roll up to this and there's a class attribute defined right here, right? So that's the
So
point.
could you like in the can you create another attribute, say species, inside the init, and then when you are creating instances, you can actually put the same species that will also work if you did not have this species class attribute, right?
So if I decided to move this in here,
Yeah,
I would have to update each instance of a dog separately. I would
okay.
have to update this one's species and then I'd have to update this one's species.
So can you not call it like where you calling age equal to 5 in dog 1? If you put comma species equal to Canis familiaris, and dog 2 also the same species familiaris. I guess it does not make sense because both of them have same species, but and then in that definition in it, you can put age comma species and then you define self dot species equal to species. Will that work?
I was trying to keep up with what you were saying, so I'm starting here.
Yeah.
Canis familiaris, right?
Yeah, and then in that
And you want me to get rid of this, right?
yes.
So we don't want a class attribute in this case.
No, I'm just saying that you can do it without class attribute as well, right? No, you have to define the
Oh, sorry.
yeah.
Yep.
And then in the self dot species equal to species, you have to do
So
that.
essentially what we're doing right now is we are moving away from a class attribute.
Yeah, like you can, that will also programmatically, it will also work, right? It should.
What did I do? Oh, I forgot. I'm moving too fast here. Right. So programmatically, yes, like you can move any class attribute to an instance attribute. The
Okay.
advantage of a class attribute is you only have to update it once to affect all instances of your class.
Okay, understood.
Yeah. And now if I want to update species, I'm going to have to do it for dog 1 and dog 2 separately.
Yes, so anything that is common to all the attributes you normally would be doing at the class attribute.
Common to all instances of the classes, yes.
Yes, okay, Okay, thank you.
Great question. Okay, I'm just gonna move this back for the purposes of posting the notebook. Is that it? What was on my changes? What did I do wrong? Oh, yeah, okay, well, that's good because there no longer is a species. So that should, there we go. All right. Delete this. Okay. All right. Example 3, attributes versus methods. So now I'm kind of taking our simple example and I'm expanding on it. This might be more realistic to what you see if you go look for class information under the hood. So I have included doc strings for everything, right? Trying to explain, hey, I made this thing. This is what it's doing. Excuse me. Right, I have my init still. I've given you some type hinting, which we saw in our functions, right? I'm saying, hey, name should be a string, breed should be a string, age should be an integer. So now I have name, breed, and age. These are all instance attributes, right? I don't have any class attributes up here above my init. So there's only instance attributes. I have this function that doesn't take anything in, but it returns the string. The name of my instance says woof. Same thing with celebrate. Again, type hinting doesn't return anything, but it does affect the age, right? So if I call celebrate birthday for my dog instance, my dog's going to get 1 year older, right? So hopefully this is maybe click on it a little bit. So you can have a method that affects some data about my instance. We'll see what that looks like. Display info. Again, it's gonna not take anything in. It's going to return a string. And all it is it's just going to give you information about that instance of my dog. So it's going to return an F string of the name is blank years old and is this type of breed. And then I can create a method that updates the breed, just like I had a method that adds 1 to the age of the dog. I can have something that updates the breed, but this actually takes a parameter called new breed. If you want to run this function, you need to tell me what the breed of the dog is, and then I will update that attribute with whatever you tell me it is, right? So if I run this, we can start looking at this. So I'm creating an instance of dog. It's called my dog. I give it a name, I give it a breed, I give it an age, right? And yep, okay. Right, so that's been created. I can now refer to my dog. I can print my dog.bark, which is a method, right? It's a method. The output is going to be Rex says woof because it's Rex. If I go look under the hood at my bark function, I get name of the dog says woof. So that's what I get. Rex says woof. I can look at the dog's current age, right? And because age is an attribute, there's no parentheses afterwards, right? That would be a method. So my dog.age output's going to be 5 because that's what I gave it. And if I celebrate a birthday, if we recall up there, we're going to add 1 to the age. And then if I look at that information, you'll see that the dog has aged, right? So current age was 5. I then run my function. I then print my display info function, which is right here, which gives me this. And that's why we see my dogs after aging. Rex is 6 years old, German Shepherd. So he's now 6 years old.
Excuse me, sir.
Yeah.
So the empty brackets, what does it do?
You're talking about this?
Yes.
Yes, so this is one difference between methods and attributes, right? So when you refer to an attribute of a class, there's no parentheses because again, an attribute just stores information. So you're just saying, give me this information about my instance.
Okay.
If you create a method, which is a function, all functions have open and closed parentheses. Some functions take parameters, some don't, right? So in my case, display info, if I go look at that, it doesn't take a parameter because self is just saying, for this instance, do this thing?
Okay.
Yeah, good question.
Thank you.
And I know when, for me at least, when I was looking at classes for the first time, I would get confused, but for me, it was helpful to always remember like, if I have a list, oh, that's a perfect example. If I have a list, right? We always looked at methods. We know append is a method. Why do I know it's a method? Because it has this open and close parentheses, right? So maybe this is a good time to do this. Right, so we remember doing this over and over. I know my list one is of class list. Now I can say that because it probably makes more sense to you, but list one is a class. Or sorry, a list is a class. List one is an instance of a class, right? So if I look at the available methods, I see all this stuff now. And I know that these are methods inside of the list class, so I can use these to do things. That's why I can use append. And if I were to like go look up the documentation for a list, I would be able to scroll to some section under the code and find like append, and it would you know, have open close parentheses, tell me what it takes, show me what it does, and that it returns the list plus whatever I passed it, right? And that's why it works that you can append something to a list. Just as if I do, let's see here, my dog, right? Now that this is a thing, I can do this, right? I see the things I created: age, bark, breed, celebrate birthday, display info, name, update breed. We're not going to worry about all this right now because honestly, you'll probably never use it unless you get super advanced into software engineering. But these are like out of the box with any class that you make in Python. It's like under the hood. Again, it's probably beyond the scope of this class, but you can see the things that we have created, right? Age, bark, breed, celebrate, right? All these things are rolled up in here. And because I made a class, we can now use our dir function. Oh, sorry.
Thank you.
All right. Had to close the blinds before my dogs went crazy. Did we already run this? Yeah, okay. All right. Example 4. Okay, I'm not gonna harp on this. Oh, I already beat myself to it, right? So we can look at dir of the dog class. I kind of just talked about that. You know, I don't know why. Oh, that's why. So these dunder methods, right? Like init, str, there's a few that you're going to see that are super common, and then there's some that I don't even know what they do. These dunder methods have an under the hood interpretation by Python, and they are used for specific things, right? So these are things we have created, and they are custom. These look scary and weird, but I'm going to give you a quick example of like 1 or 2 of them and what they do. And they may or may not be useful, but again, we can call the question mark on pretty much any object or any method in Python, and this thing's going to pop up. Although that help wasn't super helpful. When we talk about, okay. So in this case, I have pulled out 3 of these from that long list from above. STR, REPR, and EQ, right? Which stands for string, representation, and equals. So under the hood, if we were to just print our dog object, right? So print dog, or I say object. If we were to print our class, right? This is what we're going to get back, which is not super helpful, doesn't tell us much, right? What this is saying is like class, it's the main thing of the class is called dog, right? If I print my dog, which is the instance I've created, right? His name was Rex, if we recall, I get this not helpful junk right here, right? So this is the main, it's a type dog, it's an object, it's at this place in memory. Okay, not helpful. I don't know why you would need to know that. And if I just show my dog, I get like the same thing, right? So I'm trying to show you that like this is not helpful out of the box. When you create a class, right? I'm not calling specific attributes or functions. I'm just saying, what is this thing? And this is not helpful. So there are Dunder methods that do specific things. In this case, if we wanted to interact with the print function under the hood, and whenever I print my dog or the dog class, I wanted helpful information, not this junk, okay? We can interact with the Dunder method str and change how the print function interacts with our class, okay? Up to this point, print just gives us whatever it gives us, right? We print a variable, we print a list, we print whatever. It's all under the hood. We haven't messed with it. But this is a flavor of like what these Dunder methods can do. So if I scroll down to the str Dunder method, which are always identified by double underscores before and after, I can update this to say, you know what? I want it to return a user-friendly string representation of the dog. So instead of printing that nonsense, I want to return the name of the dog and the breed of the dog. Okay. So you would think we would call this, but we don't. We just call the print function, and that Dunder method under the hood is understood by Python and tied to the print function so that when I create a new dog, oh yeah, I'm just printing this long statement that's like, because I updated the Dunder method str, now the print function interprets what to display differently. So now when I print dog1, which if you recall, when I scroll up here, I print my dog, I get this junk that's not helpful. Now I've updated my Dunder str method. So when I print dog1, I actually get something else. Okay. And when I go look at dog1, if you recall above, if I just called the instance of the class, I got some junk that didn't mean anything. Now I get this helpful information. The difference between these two things is this one's in a print statement, and that was affected by updating the str Dunder method. By updating, to get something different here, I had to update the representation Dunder method, which is right here. So again, I just said, hey, take this Dunder method, return this information about my dog. And now the dog class or instance is represented differently when I call this instead of the unhelpful stuff from above. Okay. I understand this might be a little confusing, but hopefully the path is clear that like using those Dunder methods has like internal effects in Python, right? Like I'm not even calling this, but this is tied to just how Python represents the object when you call it. This affects like how the print function interacts with your object, right? So these are like under the hood have more effects than like I made an attribute and I made a function and I call them specifically. That's why these are specified with a double underscore before and after to identify that, hey, changing this has like maybe wanted or unwanted effects with Python, right? So they can be useful depending on what you're doing. The EQ function, the EQ Dunder defines like, hey, when I compare my object, how should this be treated? So EQ is, if you remember when we compare, it's equal, right? So I've defined that. I say, hey, Python, when my class is involved, I want you to interpret equal as this, which is if one thing is an instance of another, the only way that's true is if all these things are true. Okay, I'm not going to harp on this. This was just like the third example I could think of to show you like what is changing one of these things do. So dog one does not equal dog two because they have different names, different breeds, and the same age. Actually, sorry, dog one and dog two are not equal because the names are different. The breeds are the same, the ages are the same. But anyways, I'm telling Python how should you interpret how to compare two things. Okay. We already touched on that. I'm going to delete these because these are all right. I know I flew through that. I would not worry about this last part as much. You probably won't be messing with these, but now when you see them, you can have a better understanding of like they're doing some more things under the hood. We're going to take a 10-minute break and then we're going to come back, do some exercises, and then we're going to get into quickly what are different errors in Python, and then how do you install libraries, import packages. Yeah. All right. 10:38, please return. All right, one more minute. Let's find our way back. All right, 10:38. Let's roll. So we're gonna take about 15 minutes, 15, 20 minutes or so. There's only 3 exercises. I think the first 2 will go relatively quickly because they're just about functions. Problem 3, you might spend a little bit more time on because I'm asking you to create a class with some specific methods. I'm giving you like example usage of what it should look like. For all 3 of these, especially the third one, I would suggest maybe copying my code from above for a different class and changing the names and changing the methods and what they do. That might just be a little bit quicker than trying to code it all from scratch. So I will open up the rooms and we'll get going. All right, have at it.
Thank you.
Yeah.
Hello, Professor. I'm still waiting to be in the breakout group. Hello, Professor. Can you please put me in the breakout group?
Yes, sorry, I was having a coughing fit. Okay,
Thank you.
there we go. No problem.
I think I'm with.
All right, should be good.
And then so now inside the function, can we do a list? Like in a next line, then we can say the like list 1 equals to
Just a string of numbers.
yeah, and list 1 in a square bracket, right? List will be a square bracket. And then you put a list of numbers, like maybe whatever. Yeah, that's fine. And then can you scroll up a little bit? What he says, compute the average of the function numbers and return the, and then put mean, MEN, mean equals, what is that?
Okay, so this is just gonna say a variable mean and what it equals, right?
Yeah, but so average is you have to sum the numbers in the list, right? And then count the numbers. So I don't know if there is a, how do you want to do this? Because it is.
I think if this is the list that we want to average, maybe we need to make it here.
It could be, yeah.
Let's see.
Yeah, so just to help you, right? You don't want to define your list within the function, right? Because you're going to call your function and pass it a list.
Yeah.
Okay.
No. That's right. List 1, there's
Yeah.
totally fine, but underneath, you don't want to specify the exact list because that might change. You might use it on different lists.
Okay.
Okay.
Yeah.
So what do we do then?
Empty?
You don't even you don't need that line at all.
Okay.
Yeah. Because you're gonna, when you call this function, you will give it a list. So you're right now you're thinking like, okay, how do I operate on this list 1 that I'm given?
Yeah, right. So we can say what, a number?
So I have a question on that, Scott, if you're there. So
Yeah.
So we have the function and we're defining it as list 1. Where would we actually have it do the calculations on what string or set of number, or what list of numbers?
So remember, when you are defining a function, right? Python is not actually going to do anything. It's just going to say, okay, I've stored this function in memory, and now you can call this function later on to do something, right? So think about it as we are just providing the instructions right now for what it will do in the future. So So now, so in your case, you've defined a function calculate average that takes a parameter called list one. So now inside the function, we will refer to whatever list gets passed as list one. So there are, right, you could do it a complicated way, which is like how we've done before, where you like use a for loop and iterate through every number in the list and then add them up, right? But Python's been around for a long time. There's a lot of built-in functions. So one of them is sum. So remember, you need to be indented because we're inside a function. So just like tab once, there you go. So you can do sum open parentheses and then list one, right? So now that's summing up everything in your list. But to take an average, right, you got to add everything up and then divide it by how many there are. So I would,
Count.
yep, you could do count, or remember, how do you see how long a list is? You remember that?
Length.
Exactly.
So what was that?
LEN, yep. Mm-hmm.
Alien of list one.
Yep.
And
And
the average mean
Yeah.
equal to sum divided by len.
correct.
And divide is
Oh, it will be average equals sum divided by LEN equals sum. You don't need parentheses. There you go.
and like that.
So yeah, so you're close. So above you've done sum of list one, length of list one, but you haven't stored those values anywhere, right? So you need to go up and make a variable and assign it equal to sum list one, and then another variable equal to length of list one. So then you can refer to that later. You
Yeah.
know what I mean?
So like this.
So no, yeah. Well, you have to put go more left.
Yeah, in front of
Yeah,
sum.
sum equals to sum list one. Equal, yeah, and then len equals to length.
And
yeah,
yep.
I don't.
And
Can
then
you use len because it's a
exactly. So length, so LEN and SUM are functions and keywords. So for your variable name, just put something after it, like
sum underscore
go.
is fine, len
Perfect.
underscore, yes.
perfect.
And then average is sum underscore divided by len underscore.
Correct.
Um,
And then for your function to give you back something, what has to be at the bottom?
return.
Yep,
Return average.
correct.
Sorry about that. All right. So come here and do what?
Return.
Return average.
Yep, space average. Okay, so when you run that, your function will then be defined and in memory, right? It's not going to do anything. It's just the instructions.
Got it.
And then
Okay.
a cell below, you should make a list and then pass that list to your function.
So here.
Just make a new cell below this one. Like, yeah, there you go. Yep. So like my list equals, and then give it some numbers.
So would it be list one because that's what it's expecting?
No, so the parameter, that's just the name of the parameter, but you could give it
Got it.
anything that you have.
All right. My list equals what? Just a set of string numbers.
Yeah, just it could even be just like 3 numbers if you want. Yeah, that's fine. And then you need to call your function and pass it that object.
So calculate average. List one.
Equals like that.
Yeah,
Parentheses.
parentheses list one.
There you go. No. My list.
My
List. Sorry. I said yeah, and then I was like, wait a minute, no.
Oh, it's my list. Okay.
Yep.
All right.
And then if you run that, it will take your list and return to you the average.
Okay. So my only question is, how did the my list how did it recognize that list one meant this my list?
So parameter, like when you define a function, you
Mhm.
can pick any name you want. You can name it something helpful, something not helpful, right? Like in my case, list one, I would say is helpful because it tells you it's expecting a list, but like list one doesn't really mean anything to me. But besides that, parameter names it's just the name of the parameter. That's a bad
Yeah.
description, but it can be anything you want. And then because it's a function, you can then pass the function anything you want. So
Okay.
yeah, I mean, you could go
Wait,
up.
so I'm trying to put like I'm because I'm in the math class on this one. So this is essentially all you're doing. List one is just f of x, and then in the my list would be x is you're defining the input. So that's
Correct.
essentially
That's
got it.
100% accurate. You could go up and replace list one with X, and then in your function define it, replace
X.
list one everywhere with X if you wanted
Got
to. Yeah.
Perfect. I'm sorry. I'm just baby steps on this one, right? I
Yeah, no,
appreciate it.
I think that's a great thought process.
All right. All right. So we're
Numbers and numbers in decimal places, and then return round. Return the word round that you,
Okay. Um,
and just remove the calculate average underneath that you put there. Maybe that'll work.
I think what we did earlier was working, but this is I'm just kind of curious about like how this work out.
So we're saying this whole
Yeah, just delete that, and then just run it.
Comment it out for now because I think that was work actually. Because we're not calling anything, so it's not gonna return nothing. So we need to call the round after if you want to see.
Oh yeah.
So say it again.
I got one that's working right now.
Okay, what is it?
Want to share?
Yeah, I can share my screen.
Okay.
Let me see. I'm sharing the screen one. Share.
Yeah, that's it. That's the round right there. Yeah.
It took me a minute. I was like, yeah.
That's what I was thinking of right there. Yeah.
I was beating my head against the wall.
So, okay. I also got something similar to that. Oh, was this round?
Oh, share yours.
Hold on a second. Give me 1 second. Yeah, it's the same thing. Okay, I can share mine.
Excuse me. Core language problems can sometimes be like a really big pain that never get fixed. Like I have so many Spark tickets that I've submitted to be like, please fix these things in Spark, and none of them are fixed.
So you just knew you knew better.
Yeah.
The thought process of not putting float would work, but not in the program. Because it's okay, I got you.
Yeah,
okay.
Potentially.
Thank you.
Mm-hmm. All right. We're doing a class. Okay. So I'm gonna do what was suggested up here, and I'm gonna copy.
Hey y'all, how's it going?
We're working through them.
Are we stuck or are we not stuck?
I am.
Do you feel comfortable sharing your screen?
Yes.
Okay. Let's get you unstuck.
Okay. I'm still in number one because I'm just getting used to this new system that I'm using, but I'm gonna share my screen now.
Okay. No problem.
Here. This one. Share. Allows to Oh my God, that's a lot of process. Okay. Oh. Oh, quiz and reopen. Oh my God.
Yeah, you might have to. I can reassign you to this room if you come back.
Oh, okay.
How's everybody else doing? Sorry.
Okay. Trying to print. I think I got it right. I just needed to print the result. It's not printing it, so I'm like going back and forth between examples and oh. I think I got it.
No pressure. Do you want to share?
Sure.
Oh. Maybe in just a minute. Okay, where are we at? Number one?
Number one.
Okay. All right. So the function definition is correct, right? You have the name and you have the parameter that you're calling numbers. Now, in order to take an average, right? So we know numbers is going to be a list of numbers whenever you go to use the function. So, how do you take an average, right? You need to add up all the numbers in the list, and then you need to divide by how many numbers there are. And
Okay.
then we will return that. So let's first add up all the numbers in numbers, right? So let's
Oh my.
this is, I'm totally fine with this, but remove your first num equals like the line above this one. Let's delete that.
Oh, okay.
Yeah, there you go. Okay,
Okay.
so let's create a variable to hold the summation of the list. So call it whatever you want.
Can I do list?
So the function's going to take a list in, so we don't need to define a list, right? Like whenever you call this, so remember a function is like, we're just giving it the instructions of what we'll want it to do in the future.
Okay.
Make sure you've tabbed in. Indentation matters, right? So anything in a function needs to be tabbed over.
I'm trying to give it a name. Let me just give it. Okay.
Okay, and then space equals, and then sum, S-U-M, open parentheses, numbers. Yeah, there you go, just like that. But now make sure that line is tabbed in. Like indented. So go like go to the beginning of that line right there in front of my TOPE and hit tab.
Oh, okay.
Right. So now all this rolls up to the function. If it's on the same line as the definition, it's not going to be a part of it.
Oh, okay.
Yeah. So now we have a variable called my_TOPE, right? And that is the sum of the parameter numbers that we pass through. Okay, so let's make a new line, and now we need to calculate the average. That's perfect. Okay, so it's done it for you, but let's make sure we understand, right? So we have my bottom equals the length of the numbers, right? So that's how many numbers there are. And then the average, what it's returning is the sum divided by how many there are.
Okay.
So let's run the cell and make a new cell below it.
Do I tab or no?
So do me a favor and click the play button.
Okay, play button.
And then go up to the top where it says plus code.
Okay.
Make a new cell. There you go. So now we're going to call our, well, first of all, we're going to make our list. So let's make a list to pass it. So now you can do like my_list or something, whatever you want to call it. There you go. Exactly. Tab that. There you go. So you've made a list. It has 1, 2, 3, 4, 5. And now you're calling your function that you created and you're passing it the list. So when you hit run, it should return to you the average of that list.
Okay, so my question now is, can we just do these tricks instead of doing all of this? Just make a list, like my list is 1 to 3, then calculate average of my list.
Yeah, so from now on, like because you've created that function, you can
Oh.
call the function calculate average at any time without having to redefine it.
Oh, okay.
Yeah, so you could like give it another list and another list, different lists, and it's always going to give you the average.
Oh. Okay, so this is my list and then solve numbers. Then the bottom, so what does my bottom, what does that mean? The bottom?
Well, so you named it, right? That's just the name of your variable.
Oh,
Yeah. So you've just named that. So that's, I mean, intuitively that means like my denominator, right?
Mhm,
Like, I would assume that's why it picked that, but yeah, I mean, you could rename that if you wanted to. So,
okay.
uh,
But can it be the same name, like the first one and the second one? They cannot be the same name.
they could be, but you would be essentially overwriting the first variable with the
First
second one.
one.
Yeah.
Oh, okay. Okay. I'm gonna allow someone else to share that is struggling with this to share his or her screen as well.
Okay.
Thank you, sir.
Yeah, no problem. Karina, I think it was you. Did you still have a question or are you good?
I can't figure out why this isn't printing. Give me,
Well, let's figure that out.
sorry.
No,
share,
no.
copy. So,
Oh, I can tell you immediately.
oh, okay.
So your last two lines
Mhm.
are technically inside of your function, but you don't want that. You need to bring them out. No. Not that one. But yeah, those two at the yes, those two at the bottom, you've technically put them inside the function. So yeah, go backspace all the way.
Oh,
Yep. And now you're saying, hey, I've made this function and now I'm doing this thing after that.
what? Oh, why?
What's going on? Unsupported operand for type built in. Let's see. Items. So what this error is saying is that you have named something same name. Oh, no. Okay. So in your return statement, you have total sum divided by LEN, but LEN is not the name of the variable.
Oh, items.
Exactly.
Okay. Oh, my goodness. All right. Thank you.
Yeah, no problem.
One indentation above define, but one below return. So right in the middle of those of the first line.
Yeah,
and this
press
line.
backspace one more time. There you go,
Perfect.
right there.
And now I like getting user input. So user underscore input.
User underscore input
equal,
and then equals input
space
equals space input, and then in parentheses you'll put in quotes and you'll put in however you want the system to prompt its users. So enter numbers separated by spaces, colon is how I did it.
numbers separate.
Whoa.
I can't type.
It's hard to type when people are looking at you.
Okay.
Hey team,
Hi.
how's it going?
I think at least two of us, I'm not sure if the rest are having an issue or like when we type in the code, we're not throwing errors, but we're not getting anything returned, like when we use the return function.
Okay.
What are we missing?
Can one of you share your screen?
Yeah, 1 second. Let me see how to.
One.
Sorry, we've been kind of working independently and just discussing. We haven't been sharing a screen.
Oh, that's all right. One brave soul.
Okay, let's see how to.
and then I'm gonna be closing the rooms here in another minute or two, but we will fix this first.
If you need me to share it, I can, April.
Well, never mind, I see it. Can you guys see my screen?
Yes. Okay, so
Well, I've been tinkering around and I'm just like, okay, like I have the AI thing turned on because I was trying to figure out why isn't printing anything. I'm like, return result, print result. What am I doing
yeah.
wrong? Like just
See, I have totally different code than you, and I'm still also not getting a result returning.
So let's diagnose both real quick. So this is April, correct?
yeah, this is April, yeah.
Okay. So April, first things first, one function has one return statement, typically. So I see multiple returns here. Second is when you create a function, anything indented after that, right? Which in your case is every single line, is a part of that function. And we know when we run a function, we're not going to get anything because creating a function is just saying, hey, Python, I'm giving you a set of instructions for you to use later when I call your function. So in this case, you're not actually calling it, you're just defining a function. So it's not going to give you anything. So let's let's delete your last two lines, print and return. Let's get rid of those. And let's get rid of where you, okay, actually, so your last three lines, so numbers equals results equals in your print statement, let's unindent those. So put them on the same line as like the function definition. Yeah, there you go. Yep, perfect. And then the other two.
What other two?
Result equals and numbers equals, both of those lines.
Oh, okay.
Yeah. Sorry. Okay, so now if we read this, you are defining a function called calculate average. It takes the parameter numbers. It returns the sum of the numbers divided by the length of the numbers, which we know is an average. Okay, and that's the end of the function definition, right? That's your whole function. And then below that, you're, oh, yeah, go ahead.
Yes, and then how do we get an output?
Correct. So when we run this, it's going to work like a champ. So hit run real quick. And you're going to get, I think what you were looking for here. So what the difference is you essentially took what you were trying to do outside of the function definition. So instead of saying Python, hey, here's instructions to run later, and then that's it. You weren't telling it to do anything. Now we're saying, hey, here's the instructions for a function. And now I'm making a variable called numbers. I'm making a variable called result, and I'm telling you to print something. So the problem was is you just had everything inside of a function instead of like making a function and then calling the function.
Yeah, because that's why I was getting confused because I was like hitting the I was like, how do you call the function? I
Yes.
just kept rewriting everything. So I was like, print, result, return result. I'm just like, what's happening? Like it's taking everything, but it's not doing anything.
Correct. Yeah. It was all about indentation, right? So anything indented underneath a function will just roll up to the function, and it's not going to do anything until you call that function after you've defined it.
Okay, and that's what I have going on with the second problem. I did the same thing. I didn't.
Yes. Yeah, because I can see a little bit of that below, and that looks exactly the same. I think you just had the same problem.
Okay.
Emily, were you the one that was talking?
Yeah, so I had similar code, but I put like I defined average as like the sum numbers divided by length of numbers. I'm just gonna share my screen very quickly if I have time.
Sure.
Okay, are you seeing this code?
Yes.
Okay, so like for me, I did this first and then I defined numbers, then I defined like what average is, and then I printed. So I needed to do this up here.
Correct, because you are,
Okay.
yeah, exactly.
So I'm just
Exactly.
like creating an extra thing I don't need to create right here.
No, so like essentially the instructions of what average is, you did not include in your function, right? So if you just copy that line and put it above your return statement,
This?
yes. Mm-hmm.
Okay.
Copy that and put it above your return statement. So now you have said, hey, average equals the sum of numbers divided by the length of numbers, and then return average. Now, you don't need parentheses around average in your return statement
Oh,
because
okay.
return is not a function. It's like a special thing in Python. Yeah, there you go. So now if you run this, oh yeah, so your other issue is you are calling your print statement and you are calling your function calculate average, but you're not passing anything into your function right now. So after calculate average in your print statement,
Mm-hmm.
open parentheses, and you're going to pass it your list, which is called numbers.
Oh, okay, okay.
Just like if you think about it, just like I know y'all are in math class, like f of x, you got to pass it x. You just have an extra. What do you have extra here?
I don't know. I have some, I don't know if it's mad about these brackets.
No.
Oh, this.
There you go. That extra guy.
Oh my goodness. I'm sorry. Okay.
That's all right.
Okay, thank you.
Yeah. It's just like any coding language, right? Syntax, little tiny things can matter. I was on mute. All right. Looks like we're getting everybody back. A few more. All right. All right. I'm going to run through these solutions real quick. And then there are some things I want to expose you all to before you're off on your own. All right. So problem number one. Oh, first of all, most people were making the mistake of having their indentation wrong, which is totally fine because we're new. But just remember, when you are creating a function or a class, or like just like we did for loops and if statements, right? Indentation matters. So when you have your first line of, hey, I'm making a function, anything indented under that is going to be a part of your function, right? And when you create a function definition, you are just telling Python, hey, here's a set of instructions I want you to save as this function name. Oh, can you hear me?
Yes.
Okay.
Yeah, we can hear you.
Sorry, something popped up and said your internet was unstable, and I was like, am I talking to myself? Okay. You are saying, hey, Python, save this set of instructions under this name, this function name, for me to call later and for you to do something later, not right now, right? So that's how you should think about a function. I'm not telling you to do something right now. I'm telling you this is the set of instructions you're going to save for you to do something later. And what I mean by later is I made this function, I call it here. Now it's actually going to do something. It's not doing anything right here other than saving steps. So my solution is calculate average, pass it numbers. I could have named this anything. This is just a parameter name, right? I say, take the sum of those numbers, save it as the variable total. Now the average is that total divided by how many numbers there are in my list, which is length. Save that as the variable average, and then return that answer to me. And that's what's going to be the output of this function. So I create a list of numbers. I call my function, which is going to execute those instructions I defined above, pass it my list, save it as a variable result, print that result. All right, I think I saw most of you get through this one. Problem 2, update your function. Essentially take that same function and make it just a hair more complicated, which is I want it to output my solution rounded to a certain number of decimal places specified by the input to the function, right? So this looks very familiar to the top. I've added a second parameter to account for how many decimal places we need to round to, right? So I'm still passing numbers, but now I'm passing decimal places. So this total logic is the same. The average logic is the same. But now, once I have my average, I'm going to round that. I'm going to round my average, and the function round takes the number you want to round and how many decimal places you want to round it to, right? And then I'm going to return that rounded number. So I'm using my numbers parameter in my calculation, and I'm using my decimal places parameter in the round function down here, and then I'm returning it. So I have a list of numbers. I made them big long floats, and then I run my function with my list of numbers, and I'm saying, hey, rounded to 2 decimal places, and then I print my result, which will always be no more than 2 decimal places. All right. And again, this all is indented in, so it's a part of this function. And this is not indented, so it's not a part of the function. So Python says, hey, I'm making a function, and then after that function's been made, I'm going to do these things that you're telling me to do, because they're all in the same line. Problem 3. Did anybody finish problem 3? I think as I was bouncing between rooms, most folks were on 1 and 2, but maybe I didn't catch it.
Yeah, we finished it.
All right. You let me know if you did something different, but again, you'll get this notebook, so you'll be able to reference the solution if you want to try this yourself. But this was my only question on classes. So I wanted you to create a class called bank account with methods deposit, withdraw, and check the balance, right? So methods meaning they're going to do something. I want you to have attributes. The class should have attributes. Those attributes should be the account number of the bank account and the balance of the bank account, right? And then I tried to be as specific as possible. I wanted you to obviously initiate the attributes like I've done above with init. What the deposit withdrawal should do, they should add or subtract, and then this should just return the balance. And then messing with one dunder method like I did above, which was, hey, when you print the object, right, when you print your instance of the class, I wanted to return the account number and not just like random Python mumbo jumbo. So this was, you could copy and paste this to check to see if your stuff works, which is what I did down here. But walking through the class, right? So class called bank account. I essentially copy and pasted stuff from above and replaced it, right? So I have my init definition that takes attributes, account number and balance, right? And that's what you see right here, right? So these are now attributes of my bank account. I can call them to check or update them. I have a definition called deposit, which I know I wanted to, when I call deposit and I pass an amount, I want you to add that to the balance. Same thing with withdraw. I added a little bit more logic here, which was, hey, you know, if the balance is greater than or equal to 0, do this. Otherwise, if the balance is negative, right, insufficient funds or something like that. This was just a little extra to show you can like make this more complicated. But when I call with the withdraw method, right, I'm going to subtract whatever amount I passed from the balance. And then check balance is just going to return to me what the balance is. Right, return self.balance when this method is called. And then I'm going to update the str dunder method so that when I call print my account, I'm not going to get like, oh, this is where this thing is in memory. I'm going to get the account number. right? So if I run this, then I run this. I said, hey, I'm establishing a bank account. This is the account number. This is the amount of starting money in it. I'm going to deposit. And then I'm going to withdraw, right, before printing. So I'm going to deposit 500 and then I'm going to withdraw 200, right? So it went up to 1,500 and then I took away 200. So when I print the balance, check balance, it's going to be 1,300. And then if I print the account, which is the name of my instance of my bank account, I'm going to get the account number. And that's because of this. Any questions? All right. So roughly 40 minutes left. I'm going to fly through part 3 because part 4, I think, is probably the most important thing I can teach you in this whole class. So part 3 is just, hey, these are a bunch of different types of errors that you will see in Python, right? They have specific names. They have specific types. Did I ever force an error up here? Come on, I thought I forced an error somewhere. There we go. Just so you know, I'm not lying. Type error, right? And then it gives you some jazz about like a little more information about the error, right? So type error is a specific type of error. This is, you'll always see it in front of like a colon. That will give you a hint as to like what is actually going wrong. So if I come back down here to the types of errors, there's a syntax error, right? You've called a print statement, but you forgot the closing parentheses, right? That's going to be a syntax error. Indentation error, right? Where things are on the same line, but you meant to indent it and put it in between, right? Like this function is not actually doing anything. Name error, type error, value error, index error, key error, attribute error, import error, file not found error, right? So I have a bunch of examples here. Each one of these is gonna give you something different. Oh, did I say syntax error? Oops. This is a name error. Name prompt is not defined, right? I misspelled this on purpose. It doesn't know what prompt is. Indentation error, name error, X is not defined. That's the same thing as above, right? I try to call a function that doesn't exist. I'm trying to call X, which I've not defined anywhere in the notebook. So it doesn't know what that is. So it's a name error. Type error, I'm trying to add 2 different things that can't be added, a string and a number. Value error, cannot convert ABC to an integer, invalid, blah, 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 right? So I'm just letting you know, these are different types of errors. All these different types of errors can be used in like that try and except above. We were doing like that 0 division error. That's a built-in one in Python, right? You could also, check these in your except. You could say, hey, I want to print something different if there's an index error or something like that. Index error, right? It's out of range. We've seen that one before. A key error is like in dictionary. Hey, I have this very small dictionary with only 1 key and 1 value. I'm looking for, I want key B, right? And that doesn't exist. So it's going to throw a key error. This is not super helpful, right? Like you might see this and go, what does this mean? Like, why is this not okay? Like I've passed this in the right format, right? Like I'm looking for a key. I passed it as a string. What's going on? This doesn't give you a lot of information. This would be a reason to like maybe do a try and except and say like try to index my dictionary with this key. And if there is a key error, except key error, print something like the key is not in the dictionary, right? Something a little more helpful than this. Attribute error, non-existent method, right? So this is technically a string, and we know that strings have available methods, right? Like uppercase, lowercase, that kind of thing. I said dot non-existent method. Obviously, this doesn't exist. It's not available. What do you get back when you try to do that? An attribute error. String has no string object has no attribute, non-existent method, right? So hopefully this is a little helpful in kind of interpreting some of these. An import error, right? Import, this module doesn't exist. You're going to get module not found. File not found, same thing. I'm trying to open, this is a built-in function. I'm trying to open something that doesn't exist. And then the zero division error, which we saw earlier. Zero division error. All right. Those are errors in a nutshell. I'm sure you've seen some errors trying to run something that didn't work. Part 4, installing libraries, importing packages, and Python scripts. Real briefly, I'm gonna just come down here to part 5 and 6. In case we don't get to these, I have provided examples below of what these things are. Pandas and NumPy are different libraries in Python. I've also included some other common machine learning libraries, and I've provided some examples of how to ingest data like a CSV file. So right now, if you could, in our class Git, I included more files for today, such as employees.csv, Fortune 1000, Google stock prices, and Stephen math equations. Could you please drag and drop all of these into your Google Colab? And what I mean by that is, here is my thing I've been working off of. I wanted Google stock, Fortune, and this, right? These 4 files, you can just do this in Google Colab. And this message is going to pop up and you're going to say, oh, when my runtime or you disconnect, these files are going to disappear. It doesn't matter for now. You just click OK, and now they show up and they're accessible in Google Colab. So please take a second and do that. Oops.
How do you move from GitHub to Colab? You have to download first?
Yes, download those
Okay.
files locally, just like the notebook,
Okay, got you.
and then drag and drop them in here.
You have to download one by one, right?
You could go to the root directory here
Okay.
and then click on this green thing that says code and download it zip, and it'll give
Oh, okay.
you the
Got
thing.
you.
And you just gotta unzip it real quick. All right. I'll pause again once we go to use them, make sure you got them. So installing libraries, importing packages and Python scripts, probably like most important thing. What is a Python package? A lot of terms get thrown around. In Python, importing a package allows you to use functions, classes, and variables defined in that package within your code. A package in Python is essentially a directory containing multiple modules and an init.py file, which can be empty. Modules are individual files containing Python code. By importing a package, you can leverage pre-written code and libraries to perform tasks more efficiently. Let that simmer in your brain. To install a package, you use pip install and then the package name. To import a package, you use the keyword import after it's installed, and you can then bring the package into your working environment by importing it. And then once you've imported it, you can then call the package and its submodules to do things, right? And we're going to obviously put our hands on this. You can import specific modules from a package, right? So from package name, import this specific module that I want to use. So up here, I'm doing you know what, import math, the package math, and then math dot method or module to do this thing. Another way to do this is you can do from the package math. Don't import the entire package math. From math, only import this one thing that I care about. And now I can just call that thing that I care about instead of, if I import math, it's like navigating a directory where it's like math dot the thing I want to use, right? So there's advantages and disadvantages to both depending on what you're doing. If you only need one thing from a package, this is usually the preferred method of doing it. So you don't have to import the whole thing. Packages can be huge. But if you need to access more than one thing from a package, then you might want to do this so that you can call math.square root, math.exponent, math. All sorts of things, right? Similar to importing a specific module, like you can import a specific function, right? So it's kind of like we're navigating. You can go from package to module to function, like you can go all the way down. So from package name dot module name, import this function name, right? So anyways, we're gonna get our hands on this. The last thing I want to show, because this is also super standard, you're going to see this a lot. You can import a package name and then call it something else, right? So some packages have long names and maybe you don't want that everywhere, right? So one of the common things is for NumPy, you import as NP, and now you can reference NP dot whatever instead of NumPy dot whatever. All right. You can also use dir to tell you all about a package and what's available, right? Just like we've done for everything else. So let's get our hands on this, right? So example one, if we want to install a package, right? Google Colab has a lot of packages already installed, right? So I can just import NumPy as NP. NumPy is already included in Colab, so this isn't going to throw an error. If I try to import something that's not included in Google Colab, something a little more unique, something called Panda Power, it's going to throw an error and say no module named Panda Power. I don't know what you're talking about, right? So we can install a package. You use exclamation point because pip is actually a command line function. It runs in the background. It's probably above this class. If you were running Python locally, installing Python locally, you would be using pip and you would be using a command line, but for our purposes, we're not going to go there. So you use exclamation point pip install Panda Power to go tell Google Colab and go install this Python package that exists out there. And it's going to spit out a bunch of stuff that we don't really care unless it's red and says there's an error, but it says successfully installed, yada, yada. So we're good to go. Now I can call import Panda Power because I've installed the package that it didn't have. Now it has it. It might take it a second to think about it. Or more than a second. All right. So I've now imported Panda Power. I can call that dir function, and there's a bunch of mumbo jumbo. Don't worry about what Panda Power is. I'm just giving you an example. You'll probably never use it again in your life. It has to do with electrical engineering. But you can call dir to say, whoa, what's all the different things in this Python package, Panda Power. And then now just to prove that I've imported the package, right? I imported Panda Power above. I can now call Panda Power and all its lovely functionality and do things, right? So in my case, this is electrical engineering grid. I created an empty network. Again, don't worry about what I'm doing. I'm just showing you there's this package I've installed and imported, and now I can use it to do things, right? All this is built-in functionality to the Panda Power package, right? Without Panda Power, I wouldn't be able to use create line function. Python's going to go, I have no idea what that is, right? So I'm doing something. I can also, as I mentioned, an alias. I can import Panda Power with a shortened name. So the above is the exact same thing as below. These two cells are the same, but everywhere that I had Panda Power, I now reference as PP, right? So this is just an example of depending on how you import it will determine how you reference it when you're trying to use it. All right. I think that this section will hopefully connect the dots for some of you. So has everyone been able to grab Stephen math equations.py and bring it into Google Colab? Or I guess, has anybody not been able to do it and is either trying to or? Okay. So inside of this file, this is what it looks like. This is a Python script. And I know that because it ends in .py, right? Python notebooks end in .ipynb. So that's a notebook. This is a Python script.
I'm sorry, I didn't see, is the Stephen math equations PY and
Yeah, it's under lecture 4 in the Git.
okay.
Python scripts are used to build packages like store functions, create large software engineering programs, right? Like there's a lot you can do with Python. Like Python existed before the Python notebook, right? Python scripts were a thing, and then somebody came up with the idea of Python notebooks to make them more user-friendly and do analyses and things like that. So Python scripts is like the basics of Python. In my Python script, I have defined 2 functions. One's called factorial, one's called Fibonacci. Okay. What we're going to do is we are going to, this is kind of like a demonstration of when you are importing a packet, when you install a package and then start importing packages or modules or whatever, in the background, what you're doing is you are actually accessing the Python files that make up that package, right? So NumPy, right? There's a here, let me get the link real quick. Right, so if I go look at GitHub for NumPy, NumPy is very complicated and there's a lot of stuff going on, right? But inside of NumPy, there's going to be a bunch of Python files. .py. There's a bunch of sub modules underneath NumPy, such as linear algebra. This is one you're going to use if you're in the data science program, right? And I can go in here and I see more Python files and et cetera, right? So under the hood, when you are installing packages, importing packages, right? When you install a package, you're grabbing all of NumPy. And then when you are importing modules or doing numpy.linearalgebra.whatever, you are navigating in the background through those files and grabbing specific pieces of those files, right? So in my case, this is a super basic example, right? This is not even a package. I didn't have to install anything. This is a module as a Python script, right? So I can import this. It's underlined because it's like, this is weird. Like Google Colab is like, this is weird. I didn't install anything, yada, yada, but there's no error. So Stephen math equations.py is in my directory available to Google Colab. I'm importing that module, which contains this as SE, right? I'm giving it an alias. And now I can call the functions available within that module. So, oh, go ahead.
One question. So I'm in Colab and I can't import that as, it's not a notebook, right? It's looking like a plain text file.
Oh, yes. So you're not importing, you are literally clicking and dragging and dropping.
Oh.
Yep. Yeah, you only have to import when it's a notebook if you wanted to open up a whole notebook, but like any files that you just want to access in your session, you can drop and drag.
Oh, okay. Thanks.
The one caveat is if you walk away for a while or like you lose connection or, you know, your connection times out or whatever, those files are going to go away. So you need to make sure you have something locally that you can just bring it back. So once I've imported my module, which again is this Python script that holds different functions. I can then call the functions by saying se dot factorial, right? So this module, I have a function called factorial. So when I call dot, I can call my function, and then I can pass it what's required, which in this case, it's expecting one number. It's going to calculate the factorial of a non-negative integer. If the number is less than 0, raise an error because you can't do a factorial of a negative number. And then perform the factorial logic and return to me the result, right? So now if I run this, I've now accessed my module and the function within it to do something, right? In a nutshell, this is what is happening when you import a package and use some module or function from that package, right? Think about this going on in the background. Obviously, this is a super, super simple example. Pandas, NumPy, TensorFlow, PyTorch, all these, big libraries, they're much more complicated than this, but the foundational logic remains the same. You are accessing different files and doing a bunch of stuff that's being performed for you in the background, essentially. Another way to do this, right? I gave this example above. I imported my module name as SE, and then I had to say SE, I'm referencing this thing that I imported, SE dot its function, do this thing, right? Down here, I can say from this module, import this specific function. And now I can just call the function name. I don't have to do Stephen math equations dot Fibonacci or SE dot Fibonacci, right? So depending on how you import it is how you will reference it. And then finally, this is not as important. You probably won't ever, we never had to touch this in my program at least, but you can also run a Python script using standard Python, right? Like if we step back from notebooks and we go back to like, I don't even know, 19 never, when it was just Python files, you would run a Python script by calling ! Hey computer, use Python, run this Python script, right? So you can do this. Because this outputs something, I know that there's something in my file that's actually running something, right? If this in my file did not exist, if I took this away, I just have two function definitions, which we know from above don't do anything unless I call the function and pass it numbers, right? Down here, this is essentially saying, hey, if this is the main thing that's being run, if this script is being called on its own, do this stuff, which in my case, I'm saying, run this function with the number 5, run this function with the number 5. Again, don't spend too much time thinking about this because you're probably not going to mess with Python scripts at all. But if you ever see this, if you ever see some script being run on its own, know that there's logic in here that is executing something. Something's happening. Okay. Any questions on importing packages, using packages or modules or functions, anything at all? We got about 12 minutes left. I just want to make sure that this is relatively clear. Oh, I guess I could open it. So if you double click this, a preview will show up, and this is what's in that file, actually. And this is nice because it highlights the same as we see in the notebook, right? We know the definition is a keyword, has all this stuff.
Question. So if we're going to use that in Jupyter, the Stephen math equations, how do you just upload it or?
Drop and drag would be the easiest.
Drop and drag. Okay, right on the cell? Or?
Yeah, like, here, let me do this. If I delete this out of here, I can just drop it right here and then it'll show up.
For Jupyter, right?
Yeah, in Jupyter Lab.
Did you drop it from, did you drag it from that and drop it to the GitHub? From your folder, from your local folder to?
This is my local, yeah.
Okay, from local folder to this one. Okay, got you.
Yeah. any questions about importing packages?
Yeah, I have something to say. So for me, like I don't know why, I guess because I'm not on, Safari or whatever, but I had to click upload, that upload button. No, bottom,
Oh,
get out of that. Where you see files. Yeah, and that's how I had to do it.
interesting.
That
Okay, you're on Safari, you said?
No, I'm not. So that's
Oh,
what I'm saying. That's why I can't just drop and drag. I think that's why everybody's asking. I can't drop and drag. I had to like import or upload it or whatever.
interesting. I'm on Google Chrome. I'm running Chrome. I don't
You
know.
have to click the folder on the left side there before you could drag and drop. You see that highlight orange on the left side?
Oh,
Yeah,
I
you
see.
gotta do that, and then you could drag and drop.
I see. Maybe I missed the step there by telling you all, but yeah, this is where the files are. I honestly haven't used most of this other functionality. I'm not sure what this is. But yeah, if you click on the files, this is where your available files are. And sample data is always there. I'm not sure why, but this is always a part of Google Colab. You always have this. And then these are ones I dropped and dragged. Dragged and dropped. Oops. Okay. Any other questions? All right, I'm gonna try to save us 5 minutes to just take a step back and like talk about what we have reviewed. But these last two sections, I would encourage you to explore on your own. There are some exercises here if you're curious. I put a little verbiage in here about pandas and NumPy. So these are super popular, especially data science, machine learning, but even outside of that, data engineering, just statistics, like you name it. Like these have become extremely popular libraries, packages in the Python world. So pandas is primarily used for data manipulation and analysis, right? The built-in Python data types like dictionary, lists, tuples, those kind of things, extremely useful. Pandas brings its own flavor of data types to the user for usage. It's called a data frame, right? So this is not a built-in data type, right? And I know that because I have to import pandas as PD, call PD, and call the data frame, right? Data frame is a class, just like you can see that right there, class data frame. This is, just like a dictionary is a class, just like a list is a class, like data frame is a class, right? And we just like looked at classes, so we know that this thing has a bunch of methods, attributes available to you to be used. But just to get you a little bit of exposure, you can take a dictionary. That's what this is, right? We're familiar with this. That has a key name. It has the value is a list of names. It has a key age. The value is a list of ages, right? This is a dictionary. And using pandas, you can say, okay, all I have to do is call data frame, pass it a dictionary, and it's automatically going to convert it to a data frame for me. And data frames have nicer looking output, much easier to manipulate. There's just so many that there's not enough time in 4 classes to go over like what all you can do with pandas, but that has useful methods where you don't have to create your own function to take the average of something, right? Like we were doing earlier. They literally have built-in methods for like, mean or correlation or pretty much everything that you learned in your math class. I guarantee you I could do with pandas. And probably like 1 line of code per thing I need to do. So you can say, hey, I have this data frame now with 2 columns. So now we're talking about columns and rows, right? We're no longer talking about dictionary keys and values or lists, indices. We are talking about something that looks much more similar to Excel, where I have rows and columns, right? So I can access those columns by passing the name of the data frame, which I named right here, with the name of the column. Which this looks eerily similar to like how you would access a dictionary, right? or I could say, hey, give me this column and take the meat of it, right? So again, just simple exposure, not really taking many questions about pandas because we don't have much time left, but there's a method called head, which will return the top n number of rows. There's a method called tail, which will say, hey, this is what the bottom of your data frame looks like, right? But I only have 2 things in there. You can ingest data with pandas, right? So PD, because I imported pandas as PD.read CSV, and it's automatically going to take the CSV file and turn it into a data frame for me, right? I can say, hey, what's the type of this employee's object? It's going to say it's a core data frame. And then I could say, give me the first 20 rows. And we're going to look like this. Looks much more analytical than like trying to look at a dictionary. You can call describe on it now because it's a data frame, and that data frame has available methods. One of them is describe. It'll say, hey, here's how many there are. This is the mean, standard deviation, minimum, maximum, 25, 50, and 75 percentiles, right? Super useful, very quick. Don't have to do anything myself, essentially. I can say, give me information about my data frame, and it's going to say, this is the data type of each column. This column is nothing but integers. This column is nothing but floats. An object typically means a string, right? First name, that makes sense. So it's a string. And it tells you how many are blank and how many are not blank, right? Just a ton of very quick, useful information. And then again, I always come back to this because it's super useful, but we know that this is a data frame. I want to know what are the available methods I can use for my data frame. And there are so many. Right? Again, some of which I don't know what to do, but you could sort your values. You could sort by the indices, et cetera, et cetera. Okay, so that's pandas in a very, very quick nutshell. NumPy, whenever you get to the linear algebra class in Python, this is probably the most useful package. It's really used for numerical computations because it's all matricy based. So the math is fast. That's the key thing to remember why people use NumPy. Math is fast. Looking at the time. So you can import NumPy as NP. You create NumPy arrays with its specific syntax. You can add things and do matrix multiplication and dot products, things like that, right? That's what NumPy is used for. It has a linear algebra module, right? So np.linear algebra, which is that thing I showed you right here that has a bunch of stuff written in it. You can take the inverse of a matrix, the determinant of a matrix. You can say, compute the eigenvectors and eigenvalues for me. Maybe some of these terms sound familiar if you had some linear algebra in your math class for your exam. All right. Now you can step into the elevator, and before you get to your floor, tell somebody what pandas and NumPy are. Exercises here, feel free to complete them if you want extra practice or come back to them. And then I've included some extra information here at the bottom because I knew we weren't going to get to it, but there are some more advanced machine learning, deep learning libraries, right? The most popular are TensorFlow and PyTorch by far. They are essentially I couldn't say it better myself, comprehensive ecosystem for building and deploying machine learning models, including tools for building and constructing, training, deploying neural networks. So it provides a framework for you to build neural networks, which I know, at least in the AI AI cohort, there's multiple classes kind of dedicated to putting hands on, like you have theory of like what a neural network is, and then now we're going to build one in Python, right? So I'm not going to explain what all this means, but PyTorch and TensorFlow are frameworks for that. Hugging Face is a library. You've probably seen that name around if you're in the tech industry. Big on large language models, natural language processing, now some computer vision, but they have very clean, takes a few lines of code to run an NLP task, like classification of a sentence. Like, this will spit out like, oh, it's 90% sure that this is a positive sentiment or something like that, right? So Hugging Face is just a huge library with a lot of user-friendly functionality. Scikit-learn, another machine learning example, and then for those of you interested, I included an example of how to read in an image to Python. So I know we're at time. I'm willing to stay back if anybody has any questions about anything we've covered in the last 4 sessions. I'm really hoping that the notebooks that you now have access to, you can reference. You've been exposed to the basics of Python. Hopefully now, if you see things that look complicated, you can kind of digest them a little bit easier because you're familiar with the data types, how you take those data types and compare them, run loops to iterate through things. You're familiar with dictionaries and lists. You know how to make a function, or at least read one and try to figure out what it's doing. Classes, importing a package, that kind of stuff. So you're not on your own. If anybody has any questions in the future, could be during your coursework, could be something at work, I'm very accessible. I reply pretty quick to my email. I get all my accounts to my phone. So I'm definitely here to answer any questions if you're struggling to get something to work. But you're also familiar with different resources out there, such as large language models, Python documentation, that kind of stuff. So I'll stop talking. Any questions?
No, thanks a million for the last 4 weeks. Appreciate it.
Yeah, thanks for the clarity, Steve. It's a lot to go over, but I think you've done a great job. Will you put this video up then in the next day or two?
Oh yeah, absolutely. It takes, for some reason, like 30 minutes to download after class, but I always will put it up there. So yes, to answer your question.
So you put the videos in the box, right?
Yes. Yeah.
And that I know that for Blackboard, we have like once the course is over, we